welcome guys. So today let's talk about this integration. So this problem is also also common in the calculus test or even a complex analysis. So today let's use two ways to solve this. So I will provide two ways. Okay, so before I start, I hope you guys subscribe to my channel so that you will not miss my latest video. Okay, so let's see the first idea. So first idea is the standard way, right? So I mean, the standard way is that this is the standard square root, right? And then you have 1 minus y. So the standard idea is that you may guess that y equals to sine squared. Okay, so notice that y is from 0 or 1, right? So sine squared makes sense. Okay. So when y is 0, then I should use 0. When y is 1, then I should use pi over 2, right? So it becomes a sine squared. Notice that everything is positive now, so there's no other ambiguity. This data, right? So just put it 0 pi over 2. So this is a sine divided by cosine, right? So you get the sine cosine 2 sine cosine theta, right? And then you can delete your cosine. Okay, so finally you get a 0 pi over 2 sine square theta, d theta. So it's 0 pi over 2, and this is a standard one, so it's half 1 minus cosine 2 theta, d theta, right? Okay, so you don't care about the cosine 2 theta term because you can prove it will be 0, so finally you get 2 over 2 pi over 2, which is pi over 2. Okay, so this is the first idea that you can easily solve if you like to use the trigonometric substitution. Okay, but the second idea is that the second idea that you might not use, you might not think so smart to get this one, right? So another idea is that you may think, oh, the easy idea is that I let this to be u. Okay, so let's say u is a square root of y 1 minus y. So okay, u squared is y 1 minus y. So u squared minus u squared y equals y. So you need to represent y, right? So y is y is y, right? So y is 1 plus u squared, okay? So so I can write 1 minus 1 plus u squared, 1. So dy will be 1 minus u squared square, and 2u du. Okay. Okay, so very happily we can keep solving. So this guy become a u times dy, right? So it's 2u du, 1 minus u squared square. So 2u squared du, 1 plus u squared square. Okay, so notice that if y is 0, which you got what? You got 0, 1 minus 0 square root. So it's 0. Y is 1, you get infinity, right? So here. Okay, so that's why I think you will involve complex analysis. So there's you have two ways to solve it. The first way is to use complex analysis, and the residual theorem, Cauchy integral, which is I will not use it. Okay. The second idea is that we use elementary way. I mean, if you want to use complex analysis, then you can try by yourself, which is not very. It's very easy if you know enough about residue theorem. Just take a residue, right? And you are saying that these guys like the two pole. Okay, so not very difficult. But maybe elementary way is not so bad. So it's 0 to infinity 2u squared plus 2. Okay, so maybe let's do the partial fraction. Okay, so the idea is that you can write as this, right? And separate into two terms. So first term become this, right? And the second term become this. 2, right? So you can pull out your 2. You can pull out your 2 to become this. Okay, and this term, this guy is so-called. This guy is arctangent u, right? Infinity to 0. So this guy is pi over 2. Times 2 minus the following term, so 0 infinity du 1 plus u squared square. So this guy is infinite. When you put infinity, pi over 2, right? So pi over pi minus 0 to infinity du 1 plus u squared square. Okay, so final is you to find it. So you can still use complex analysis to do this term, right? But let's assume that you don't. So so the standard substitution is u equals to tangent phi. So it become second square phi, second square, right? But square, so second for phi, and second square phi, d phi. Okay, so when you use 0 and you get 0, right? When you use infinity, you get pi over 2. So this is pi over 2, 0, cosine square phi, right? d phi. And this is easy to prove. It's the same as which is oh sorry, there's a 2 here. Sorry. So pi over 4, right? So you get pi minus pi over 2, which is pi over 2. Okay, so it's the same as our first answer. Sorry, since I missed 2 here. Yeah, so okay. So the only thing is it's still the same, right? So once you understand this, then it's very trivial. Okay, so maybe I will give another video that using a standard trick to prove using a complex analysis to compute this integral. Okay, so see you guys in the next videos.